Hello, Algebra 2. We are going to do lesson 7.2.3 right now, and we are going to dive deeper into this idea of the period of a cyclic function. Okay, now remember, cyclic functions are functions that repeat over and over again, and most of the time that is within the realm of trigonometry, so sine, cosine, and tangent. Okay, so last lesson we really completed what we call the general form of a trigonometric equation. So a lot of times I've been using sine, so maybe I'll use cosine for this one. So let's just review what that is. Okay, it's very closely related to what we did with parent functions in chapter 2. But we have y equals, okay, then our a, which stands for amplitude, times the cosine of, okay, we wrote two forms yesterday. I'm going to write the one that we're going to focus on for the next few lessons. Bracket, and we have b, then times x minus h. Now that minus h controls the horizontal phase shift. And then we have plus k, which controls the vertical shift, where that midline is. And so kind of the new idea yesterday was this b right here. And that b told us some information about how many cycles fit within a general span, which then allows us to figure out how long one cycle is. So this b has everything to do with the period of the function. Okay, now non-cyclic functions aren't going to have a period. It has to be repeating. So by the end of this lesson, we will have the tools that we need to find the equation for any sine or cosine graph, and then we'll be able to graph those. Okay, so we're going to start pretty basic, focusing on this idea of the period, and then from here on out, we'll kind of see more complex functions. So on 138, this is just getting our mind thinking beyond just trigonometry for what the period of each situation would be. Okay, so the period, remember, a synonym is cycle. So how long is one cycle of what is described? So on this first question, on question A, it says the input is the angle, theta, in the unit circle. So immediately you're thinking kind of, how long does it take to travel around the unit circle? And the output is cosine of theta. So if we picture that unit circle, okay, where do we always start? We start here at 0 radians. And then when we go ahead and travel around the unit circle, this represents all different angles that have different cosines. And then we finally return to 2 pi. So the period of the unit circle is 2 pi. One lap around is 2 pi radians. So then on B says the input is time, and the output is average daily temperature in New York. So if we want to describe an entire cycle of time with the daily temperatures, really we're thinking about how many days do we need to track? Well, the length of one cycle would be a year. We need to know what the temperature was on average each day. So 365 days make up a period in terms of this scenario. And then on C, okay, C says the input is time again, but then the output is tide of the ocean. Now, I don't think this is as common of knowledge unless you visit the beach often, okay, but the tide at the beach, you have high tide and low tide, okay, and every 12 hours, the tide reaches its highest and its lowest. So we would say that one period is 12 hours. So how many cycles are there in one day? We could say that there are 2 periods, 2 cycles in one day. So a lot of times high tide will hit once during the hours when residents are actually on the beach, and then high tide will also hit in the middle of the night, and so that's where it kind of washes things up onto shore, seashells, animals that you see when you walk along the coast. Okay, so that's just kind of relating beyond trigonometry, but now for the rest of the lesson, we are focusing on cycles within trig functions. So it says on our graphing calculator, or Desmos, they want us to complete this problem. Okay, well, we are spoiled, and I've went on Desmos and created each graph for you, but I do recommend that you go onto your graphing calculator and think about, how are we going to start graphing trig functions? Well, you need to first of all make sure you're in radian mode, okay, because we're dealing with radians, not degrees. Also, when we look at the domain and range in our viewing window, so if you go to your viewing window, you need to adjust that, because right now it would be from -10 to 10 on both the x and the y. Well, if we think about our parent function, what is our parent function? Sine x. This is the parent function. Whoopsies, what's going on here? Okay, what is the domain and the range of one cycle of our parent function? Okay, well, for the window on the x, your x min would need to be 0, and your x max would need to be 2 pi to see one cycle. Okay, and then how about the range? For the range, we're really thinking about the amplitude of the parent function. So we would just need to simply see from -1 to 1 as your y min and max. So you might write yourself a note that range deals with really the amplitude of the trig function that you're considering. So what we're going to do is separately look at 4 different graphs. You can see what the 4 graphs are. Okay, they are y equals sine x, they are y equals sine of 0.5x, y equals sine of 2x, and y equals sine of 3x. And we're going to kind of answer a series of questions, but if you notice the viewing window on all of these, goes from 0 to 2 pi. Every single one of these 4 graphs, the viewing window is 0 to 2 pi, which that is the domain or the length of one cycle for our parent function. So again, let me stress the importance that you need to really be an expert on the parent function to understand all of the transformations of everything else. So if we look, okay, this is a review from a few lessons ago. If we're graphing y equals sine x, okay, we see that we start at 0, 0 because the sine of 0 radians is 0. Then at pi over 2, which is halfway between pi over 3 and 2 pi over 3, is going to be the peak of our mountain. Then at pi, the sine is 0 once again. And then at 3 pi over 2, which is going to be between 4 pi over 3 and 5 pi over 3, that is the lowest point of our valley. And then we return back to 2 pi. So let's answer some questions about what is going on here. So the first thing I want to know is, how many cycles occur in the length of 2 pi? Okay, well, one cycle of sine, we have to see the peak, we have to see the valley, and then we have to return back to 0. Okay, so how many cycles do we see here? We see one cycle. Now for the equation of the midline, remember the equation of the midline relates to that value of k, but we can see there's no k tacked on in the equation, so our midline is simply the x-axis, which, what is the equation of the x-axis? Y equals 0. And then the amplitude is the value of a, but we see that there is no number out front of sine, so the amplitude is the height of the peak or the depth of the valley, so the amplitude is 1, okay? And then the period is the length of the cycle. So how long did it take us to get through the cycle? Well, in the parent function, we've already established it's 2 pi. And then finally, I keep calling this a function, but is this equation truly a function? Now, this is a quick review. What is kind of the rule of thumb that we use for function? We can use the vertical line test. Okay, and the vertical line test looks at, is there only one output for each input? So if I draw some vertical lines, okay, my vertical line is only slicing the function at one point. So is it a function? Yes. And I'm going to go ahead and say that every sine and cosine wave is going to be a function. Okay. So now we are going to look at a different function, which is still related, but it's y equals sine of 0.5x. So first of all, we again notice that we are going from 0 to 2 pi. And this is sine. So we know that the parent function of sine goes up to the peak, down to the valley, in return. So this is what one cycle has to look like. Well, I see the peak, but I do not see the valley. So how many cycles is occurring in this case? We don't even complete one cycle. How much do we complete? We complete 1/2 of a cycle. Okay, so it seems like this wave is being stretched out. Again, okay, though, we do see the start of the peak and the end of the peak, so the midline still occurs on the x-axis, so we have y equaling 0. The amplitude, if we look at the height of the peak, what is that distance? It is 1, and again, we see no number in front of sine, so that is not shocking. And then now we need to consider, what is the length of the cycle? If we only see half of a cycle happening between 0 to 2 pi, what am I going to have to do? I'm going to have to double 2 pi in order to see the valley take place to get back through one full cycle. So what is the cycle length? It's 2 pi times 2. We have to double it. So what's 2 pi times 2? Is 4 pi. So that is the length of one period. If I would say how long is the period, the answer would be 4 pi. Again, is this a function? Is there one in our output per input? If you were listening, you would say, I see that it is a transformation of sine. Miss Steffen said all sine waves are functions, so the answer here would be yes. 2 more examples. Okay, some of this is repetitive, but you're seeing kind of the main point come across, hopefully, as we go. Okay, so now we're being asked again about cycles, and we need to be good about recognizing that full S shape take place. So let's go ahead and look at, let's highlight until we get back to the beginning to see how many cycles there are. So I'm going to start. I see my peak, I see my valley. That is one cycle in orange. Then if I go ahead and change my color, I am going to highlight my next cycle. And there is my second cycle. So how many cycles occur in 2 pi? I see that 2 cycles, 2 full cycles are completed. Now, looking at where I began, where I ended, okay, that once again establishes my midline, which is the value of k. There is no number being added at the end. You could look at that as plus 0, if that's making more sense to you. So our equation of the midline is still the x-axis. There is no vertical shift. The amplitude, what is the height of the peak? The height of the peak from the midline is just plain old 1. And then now we're looking at what is the length of one period. So if we focus on the orange, what did it take to get from start to finish of one cycle? Well, it's half of 2 pi. So you can see the labels on the axis, but basically it's 2 pi divided by 2, which is pi. So the length of a period is pi. Which makes sense that then if the period is pi, how many cycles would fit in 2 pi? It would be 2 cycles. Is the equation a function? Yep. Once again, one output only one output for every input in the domain. Okay, and then finally, we are looking at one more example, which is y equals sine 3x, and we see that we're starting at 0, our viewing window ends at 2 pi, but to determine the number of cycles, okay, we're going to get out our highlighter, and we see that the first cycle, we go up our peak, down to our valley, there's 1. Then we see up to the peak, down to the valley, there's 2. And then finally we go up to the peak, down to the valley, there is 3. So we have 3 cycles occurring in 2 pi when our B value is 3. Let me stress that. If I backtrack, what was our B value on the last one we did? It was 2, and how many cycles were there? 2. So hopefully we're remembering that from yesterday. Now, if we look at our midline, nothing changes there because that is the value of A. There's nothing in front of sine, so we know that that is just y equals 0. Or sorry, not our value of A, my bad. That is the value of K, and we see nothing at the end, so that's 0. Our amplitude is controlled by A. Okay, nothing's in front of sine, so if nothing is the coefficient, then we know that the amplitude is going to be 1. And then what is the length of the cycle? Well, if we know that 3 cycles fit in 2 pi, can I go ahead and just take 2 pi divided by 3? And then I see, okay, 2 divided by 3, that's 0.6 repeating, so I just want to leave that as 2 pi over 3. Now, if you look, read the label on the axis, where did our first cycle end? At 2 pi over 3, but I'm just kind of showing you that we could predict that without relying on the scale, because the scale won't always be provided to us. So if I take 2 pi over 3 and I multiply it by 3, what is that going to get me? That's going to get me 2 pi. What did I just do there? I was checking to make sure that 2 pi over 3 does fit into 2 pi 3 times. Okay, so that's just kind of re-emphasizing the idea. Finally, is the equation a function? Yep, it is a function. It passes that vertical line test. We are good to go there. Okay, so let's just kind of pull everything together with the key idea that we saw yesterday, but hopefully you're catching on. It's very important, so we're going to see it again today. What is the relationship between the period of a sine graph and the value of b in the equation? So all 4 of those functions, we were looking simply at y equals the sine of bx. Okay, we had no transformation in the amplitude, the horizontal shift, or the vertical shift. So we want to think about, what does that b truly mean? Okay, well, if we look up above, when b was 2, there were 2 cycles. Okay, when b was 3, there were 3 cycles. When b was 0.5, there was 1/2 cycle. When b was 1, there is 1 cycle. So hopefully you've caught on that b represents the number of cycles that occur in 2 pi. Now that's important, okay, because if you just said b represents the number of cycles, well, cyclical functions are usually never ending, so you have to specify that it's the number of cycles that occur in 2 pi. Why is 2 pi so important? Because it is the period of the parent function. Okay, now further on, okay, we really usually care about just 1 cycle. That's usually what we kind of dive into to analyze. So the length of 1 cycle, and I started to kind of emphasize this through our examples, which we're usually going to call it the period, because that is the vocab word used for length of a cycle, can be found by taking 2 pi and dividing it by b. If there are 3 cycles, that is b, then how are we going to find the length of one cycle? Then we're going to take 2 pi divided by the number of cycles. Okay? So, I'm going to leave you with that today. Just really get used to the idea that b is not the length of the period, it is how many cycles fit in 2 pi. Therefore, we can find the length of the period by using this quick division of 2 pi divided by b. Okay, so that is the end of the lesson. Make sure to do your 7.2.3 homework. Keep up the great work. Keep enduring through. I know it's just an unusual time, but I really appreciate everything that you guys are putting into this. You will see the benefits. So I will talk to you next time.